Hey everybody, welcome to another stream. We're going to talk today about setting up a machine for horizontal. So I need to, we've got a record. Looks like we're having trouble. Oh, sorry about this, guys. Looks like I'm having some technical difficulties with the webcam. Um, we'll see if during the broadcast, if the webcam keeps messing up, I might switch to, I'm using it's like a Microsoft Studio Life Cam. It's not a very expensive camera. I think it was about $40 when I bought it probably 5 years ago. So I've had it for quite a while, and it seems to be a little flaky. If I touch it, it seems to be kind of a little glitchy. So if I start glitching because of the life cam, I'll try switching to just my regular laptop webcam, although it's not nearly as HD. So let me send a quick invite to a couple guys. Let's see. I'm not sure if that's you, Tom. Let's see. So, just interacting with a couple of guys. See if they're going to join the broadcast. Okay, so sent a couple of invites. So what we're going to look at today is taking kind of a part that's been programmed previously on a vertical machine, and we're going to go through and set up a post processor for a horizontal machine. So the first thing that I typically do, let me grab this new tab. I'm going to go to eMasterCam, and I like to use copies of their MP Master post processor. So I'm going to go to Downloads. And over on the right hand bar there, I'm going to go to Post Processors, and I'll go to MP Master, all versions. And we've got MP Master version 2021. So I'll navigate here and I'll say download this file. So I'm going to do open containing folder, and I'm going to take it from my downloads folder, and I've already got a folder configured in my documents. So I'm going to set this post up for a Methods brand MH320A, which is a horizontal machine with 320 millimeter pallet, so just right about 12 inches. Actually, if I go in there real quick, so yeah, it's about 12.6, 12.59843. So it's a pretty fast little horizontal. So it's a nice setup. Looks like I'm having a little bit of issue with my webcam. Sorry, guys. Let me, let's see. That's the integrated webcam. If I go back to the live cam. Hold on. Sorry, guys. I'm just messing with my inputs here. That's better. Hopefully. There we go. Yeah, my live cam. My webcam that I've had for quite a while it's kind of been acting up lately. So it's probably time for me to invest in some new hardware. Probably time for me to get a new webcam. So sorry about that, guys. If it keeps going in and out, I may have to try and switch over to my integrated webcam. So I've downloaded a copy of MP Master. It's MP Master 2021, and I like to use a program for dealing with zip files called 7-Zip. It's a free software out of Germany for dealing with zip files. It's a really great. Kind of much better than WinZip, since it's not, since it's actually freeware and WinZip is not. You actually have to pay for a license of that. So I'll go ahead and open it up. One of my favorite things, under the View menu, there's this option called Flat View. And what Flat View does is it shows you all of the root files that can be buried in folder paths. So if you open up kind of a normal zip file without the flat view turned on, so for example, if I just go into view, turn off flat view, it's fortunately in this case we've only got one folder, but sometimes you can have files that are located 10 folder levels deep, and they can be difficult to go through the process of extraction. So here I'm going to go to view and say flat view, and what I'll do is grab all 4 files, I'll select them, and I'm just going to drag them and drop them into my Windows Explorer window over here. So I've extracted them from the zip file and located them in this folder here. It's configure MH320A. Oh, hey Tom. So I see you in the chat over there. Welcome. Hey guys. So we're configuring a machine for a horizontal. So this part was previously programmed on a vertical, and I'm in the process of setting up a horizontal 4-axis post processor. This is for an MH320A, which is a Methods brand machine. It's a very, I don't want to say just small, but it's a compact horizontal 2 pallet change station. So it's got a built-in pallet changer, very small footprint, but a very full-featured machine for that footprint. So I've got some sample code that I'm going to attempt to make my output match that sample output. So when I look at a post processor and I look at the NC code that I'm getting out of the post, we have to relate that in some way back to the Mastercam file. And the way we do that is through a series of operations. So in Mastercam, we have a series of instructions to the post processor that we tell the post, all right, I want to take a tool in 3D space and I want to move it over and I want to cut with it. And when we do that, we get an operation. And that operation itself has got some events that happen automatically in the post processor. So we have a header that comes up in the post. In the post header, basically, we're going to choose some output of some file strings, typically things like the file path, the file name, and then you're going to have things like potentially material list. So you might have your material described there. You might have a tool list. There's all kinds of things that you could end up describing up in the header. And after you get through the header, you're generally going to come to your first operation. So your first operation is going to be output through the start of file post block. So it's PSOF. We'll take a look at a couple of these things. But so in general, when we're talking about operations, there's two types of operations. There are tool change, where you've got it's either the first time a new tool is used, or you're switching from one tool to another. So you might have tool 5 and now you're going to tool 7, or you've got tool 1 and you're going to tool 2, or you might have 2 and you're going back to 1. So there's an actual physical tool change at the machine. Then you've got a case like these two ops right here, operation 1, operation 2, and operation 3 all use tool number 1, and they all use the same WCS and tool plane. So WCS A0, tool plane A0. And by the way, we have control over the display of information here in the Ops Manager. So for example, if I right click and I go to display options, we can turn on, for example, I've got the compensation construction plane turned off here, because it adds to the length of these strings without really telling me much extra, because I pretty much always have the same construction tool plane set, like 99.99% of the time. So I go and right click and go to display options, and I turn off the comp and construction plane. Sometimes I will also turn off operation type and turn off WCS, so that I can really kind of filter down that data. So for example, if I want to just look at the tool planes, I can turn off the display of the other info, and now I can see a little bit, a little bit more easily which tool planes are in use. So let's go back in there. Let's turn back on WCS and back on operation type. So this particular part file was programmed for a vertical. I want to change over to a horizontal. So one of the, I don't want to call it a difficulty, but one of the differences in Mastercam between programming a vertical machine and programming a horizontal machine is the use of planes. So in Mastercam, if we go to the plane manager, I'll back up just a little bit. You'll notice I've got this gnomon on the screen. I believe I can do, one second here, plane gnomon settings, and let me increase the size of these axes. So I'll bump that up a little bit just to make it a little easier for you guys to see on the screen. The other thing that we can turn on now that's new, it's a pretty recent addition to Mastercam, is this plane display. So you notice there's an option here that says only when highlighted, which means only when it's selected in the list. But I can turn on and off this grid on that plane. I can dial down or dial up the opacity, so the amount of light that's kind of either allowed or not allowed through that plane. And I can adjust the size of the plane, kind of relative to the part that's being displayed. So I'll adjust this a little bit. And this is really, this plane thing right here, show plane, that's really just a visualization tool. So it helps you to understand how is the plane oriented relative to my geometry. So I'll select OK here, get out of this plane gnomon settings, and as I click on these different planes, you can see how that plane orientation A0 is right up there, A90 is over here, and then we've got A minus 15. So one of the things I noticed when I looked at this file, and it's not really necessarily a bad thing, I guess more of just a personal preference, you'll notice that we've got the WCS and the tool plane the same for all of these operations. And this is really just a personal preference thing. When I like to set up these horizontal machines, I like to set them up where I've got a single WCS, and that WCS is the part mounted on the machine, and the WCS represents the machine coordinate system. In Mastercam, we call it a working coordinate system, WCS, because we can move that coordinate system in 3D space, so we can do translation, and we can also rotate that 3D coordinate system, so we can reorient it as well. And my preference is to have the WCS set to how the part sits on the machine in the real world. So if I've got a part and that part is sitting on my machine like that, however the part is oriented, that's what I want my WCS to look like. That's, part sitting on the machine in the real world. And then my tool planes are going to be every time I rotate either the part or the machine so that the tool is oriented in a different way, that's when my tool plane is going to change. Let me go ahead and do change the input. There we go. Okay. So I'm going to reprogram this thing using what we call the top front method. So with a horizontal machine, typically the way we set it up is to use a top WCS and the front tool and construction plane for rotary B0. So the special combination of top WCS, front tool and construction plane, there is some logic in the default Mastercam posts to detect that orientation. And when that orientation is detected, it recognizes in the post processor that the machine is a horizontal machine. So this Mastercam post, MP Master, can be set up to drive both a vertical A-axis machine and a horizontal B-axis machine from the same post. And it's the machine definition that is really, it's two things. It's a combination of the machine definition you're using, so we're going to use a horizontal machine definition, and the plane combination. So top WCS, front tool and construction plane, that's what's going to signal to the post processor that we're actually using a horizontal machine. So what I'll do here, by the way, when we set up a post processor, we're really talking about setting up three things. So it's a machine definition, a control definition, and the post processor. Kind of a best practice is to always make sure that we're naming all three files the same thing, the exact same name, to kind of designate that the three files go together. Because otherwise it can sometimes be really hard to track down which machine definition, control definition, and post-processor combination actually output my NC code. And this is a valid question. File management, file organization can be difficult enough. So one of the things I like to do is just make sure I'm, just giving as much description as possible in the actual post-processor, control definition, and machine definition filing. So I'll do this real quick. going to create a folder called 2021 MP Master. And I am going to copy all 4 of those files into this folder. That way I have backups that I can refer back to just in case anything got messed up. Here I've got MP Master mcam-control. That's my control file. I've got mpmaster.post. I've got MP Master horizontal and MP Master vertical for my machine definitions. I'm going to go ahead and delete the vertical machine definition simply because I don't need it in this case. So why do anything that's confusing, right? So I'll go ahead and choose to name this thing. So this is an MH320A machine. And what I will typically do is put some kind of information about the machine configuration, so not just the name of the machine, but what type of machine is it, and then the control that's used on the machine. And the reason I like to have it in all 3 file names is just so that you get as much out of the description as possible. So what we're going to do is say MH320A, it is a 4X, we'll do dash HMC because it's a horizontal machining center. And so that describes the name of the machine, the type of the machine. We're going to say it's got FANUC 31I. We'll just, even though it's got a 31IB5, we're just going to leave it so that the file name doesn't grow too big. And then the very last thing I like to put here, because it helps me manage my files, is the actual Mastercam version that the post, the machine, and the control file are set up for. I find this to be very incredibly useful. So I'm going to say mcam 2021. So before I finish here, I'm going to hold down Shift and use my arrow key to select the entire file name, and I'll do Control C for copy on my keyboard. So I've renamed the post processor MH320A. It's a 4X HMC with a FANUC 31i, and it's set up right now for Mastercam 2021. I've copied that file name. So I'm going to go ahead and rename the control file and the machine definition just by copying and pasting. So all 3 files share the exact same name, and it gives me a good description of what the machine is, what the capabilities of the machine are, what kind of control this is set up for, and what Mastercam version it runs with. You don't have to include the MCAM 2021. You don't have to include, you can make your file name as simple as you want. If you've only got one machine that you're programming for, you don't necessarily need to get this complex. But when you're sharing multiple machines, multiple machining types, different controls, the other thing that I consider putting in my file name is probing. So if it's got like a Bloom probe, or if it's got a Renishaw probe, or if it has no probe, I might put that in there. No probe, Ren probe, Bloom probe. Just to give, again, as much description as I possibly can to just the file name itself. All right, so we're setting this up for a horizontal, so let's go ahead and do a little bit of kind of the base configuration. once we rename those files, we really need to tell Mastercam where the files are and that those files are linked together. So I've got a thread that I created on eMastercam that goes through control definition defaults and kind of some information about setting up the Mastercam machine and control definition files. But we'll go ahead and just go through the process here. If you've got questions, by all means, type in the chat box. I'll try to address, what I can as we're going through this. So what I'm going to do is save my part file, and I'm just going to do file new, because I like to start with an empty Mastercam database whenever I'm working with machine and control definition files themselves. In the MP master post that we renamed, I'm going to go ahead and open that up. And I'm going to open it up with Code Expert. I've automatically defaulted Code Expert to be my default file program for opening .pst files. Otherwise, if I hadn't have already associated the file, I'd have to go to my PST file, left click to select it, and then right click and choose open with. So for the open with here, if I go down and select choose another app, you'll notice here in my list, I can click on more apps. In order to get this to always come up, click on always use this app to open PST files. But now I'm going to scroll down to the bottom and choose look for another app on this PC. So it's going to dump me in C program files, and now I need to go find my Mastercam. So I'm going to go down to MCAM 2021. We'll go into the Mastercam folder, and then we're going to go to extensions. It used to be common editors. So if you're using an older version of Mastercam, like Mastercam X5, you used to have to go to the common editors folder, but now they've put it in the extensions folder. And what I'm looking for is codeexpert.exe. So CodeExpert is going to be your best tool for working with a post processor, because if you open a PST file, it will automatically do code recognition. So you'll notice that between these user variables, user-defined variables are just shown in black, but my predefined variables are actually shown highlighted in blue, and that's when I add that $ to the end. So if it is a valid predefined variable, it will highlight that variable for us. And by the way, in file options, under my document settings, I've got white space turned on so that I can see the spaces, and I've got auto convert tabs to spaces turned on. So if I turn off my little white space display, you'll notice that my dots in between go away. So this may be easier for some of you to read through the code, so I'll try and leave that off. However, if I've got that on, so I put some tabs and spaces here. And if I don't have the white space markers turned on, it all looks the same. But the post engine treats tabs and white spaces differently. So if I turn on my little white space marker, you'll notice Oh, because I've got auto convert tabs to spaces turned on. So if I turn off auto convert tabs to spaces, you can see that tab characters are these arrows, these little blocked arrows that are equal to a certain number of spaces, but they're not actually space characters. So it's really important that we actually use space characters when we're working with posts. So I'm going to turn that back on. All right, so up at the very top of the post, this is an MP master post. It is set up for mill. The machine name, I'm actually going to paste in some info here. So we're going to say this is a Methods MH320. It's got a FANUC 31i B5 controller. The description is going to be a 4-axis horizontal post. You notice it's already set up for 4-axis. It is not set up for 5th, so this does not support 5-axis programming. And down here we've got a revision log of some of the changes that have been made. This is one of the reasons I really like this post processor. It's got a ton of functionality, including things like high-speed modes that are already incorporated into the post processor. So let's make sure all this is named correctly. That's all good. Okay. Up at the top of the post, underneath the revision log, oh, and by the way, I'll put this in here. Let's put in a comment. This is going to be for '21. Okay, so we put a little comment that we're setting up this new post for the MH320A. So let's see what kind of output we're getting by default. In order to check the output, I'm going to go ahead and save that post. We need to get everything linked together. So we need to link together the machine def, the control def, and the post processor. I like to start at the post level. So first thing I'm doing is going to go into the machine tab, and I'll go to my control definition manager. So edit control definition, and I'll select open. And you'll notice right now it's going to set us to look in C, users, public, documents, shared mastercam, 2021 CNC machines. So that's where we're looking by default, is in the shared mastercam folder under the public user. So it's users public, which is fine. But right now all of our files are located kind of in a project folder. So here's something you should be aware of. When we work with files, when we work with a post processor that is in the same location as our mastercam file, it will actually always go to the local copy of the post processor. When we set this up, in order for the file paths to be correct, rather than working from just a random, my documents file location for only my username, I'm going to go ahead and put these files in the correct spot. So I'm going to open up another Windows Explorer, And let's go to shared MCAM 2021 CNC machines. And then here I'm going to grab my machine and control, right click and hold, and then drop, and I'll select move here. Then I'm going to go shared MCAM 2021 or shared Mastercam 2021, and we're going to go to mill. We're going to go to posts. And here's where I'm going to move that post. So it's not going to conflict with the normal way that the posts are set up, which is to use the public documents shared MCAM 2021, whatever your Mastercam version is, shared, MCAM X9, shared Mastercam 2017, shared Mastercam 2021. So we've added that in here. And in my Mastercam file, again, I'm going to go control definition. We're going to go to open the control definition. And here, because I'm now in shared MCAM or shared Mastercam 2021 CNC machines, I've got access to the MH320A Forex HMC. So I open that up, and by default, you notice over here on the manufacturer, it's got all these different manufacturers. Because this is set up for MP Master, it could work for pretty much anything, but we're going to set this up right. So we'll say MH320A. The description, this is a 31i B5 control. And if we look at the post processor drop down, and I click down here, what you'll see is a default file path for MP Master. So the default file path is C users public, whatever Mastercam version you're in, mill posts. And then inside that mill posts folder, you're going to find whatever your post file name is. In this case, MP Master, but what we want to do is add the new post that we've configured. And all we really did to it so far is add a comment and change the file name. We haven't done anything else to it yet, but that's coming. So I'm going to go to post processors here, and I'm going to go add files. And I'm going to grab my MH320A post that I just created. Now, while I'm in here, I'm actually going to select MP Master and press delete. And the best way to do this is actually to show you the most proper way to do this is to set up the defaults first and then add our post processor. That's the best practice way of doing this. So I'm actually going to delete that out and say okay. And I should only have my defaults. So I'm going to set the defaults first. I could have added my post, set up my post, and then copied all of my default or all of my post settings over to the default settings. So there's multiple ways to do this, but I'll just show you kind of the best practice way. So I'm deleted everything out. I've got my default set. I'm going to press save. Now I'm going to go through and set up my tolerances. So NC precision. We've got 5 decimal place in inch and 4 decimal place in metric. You notice it says minimum step value. Chordal deviation used in post. So chordal deviation is used when we're talking about things like breaking arcs. If we're breaking an arc into line segments because we're converting it inside the post. That's where this chordal deviation is used. I'm going to set this to 4/10, which is 0.01 millimeters, just because I like those numbers. I like my numbers to match. So whatever the inch value is over here, whatever value I'm going to use, I really do want to do the conversion so that it's kind of properly set over here in metric. Deviation of vector endpoints for planar detection. Right now it's set to 50 millionths. I'm going to go down to 20 millionths. And 20 millionths is actually about half of a micron. So I'm going to make that about half a micron there, 0.0005 in metric. So general math function in the post, 1/10, that's probably okay. Yeah, we can add another decimal place of precision. So 10 millionths over here is really, this is about 40 millionths. So we would want to go 0.25, make that match. This is where we really get into the important values. So minimum distance between arc endpoints, minimum arc length, minimum arc radius, maximum arc radius, minimum change in arc plane for helix. By the way, down here, minimum angle tolerance in degrees, maximum in degrees. This is really for wire EDM, so we really don't need to worry as much about these two settings for setting up a mill machine. So the distance between arc endpoints, right now it's set to 5 thou. So if you think about it, if you think about an arc and you're measuring the linear distance, the linear 3D distance between those two endpoints, 5 thousandths means you're kind of limited in the small arc size that you can create. For minimum distance between arc endpoints here, I'm going to set this to like 2/1000 of an inch. 0.01 is about 4/10. So we're going to make this 0.25. Let's just check this here. So we'll go inches to millimeters, 0.002, 0.05 millimeters. So we're going to do 0.05. Minimum arc length. So the minimum arc length, I believe, is a measure along the circumference of the arc. So I'm going to set that to 4 thousandths. And that would be more like 0.1 millimeters. Minimum arc radius. So these are the numbers that get passed from the Mastercam toolpath operation to the post processor. So in Mastercam, if you have an arc that is smaller than this value in the toolpath, it will automatically get converted. It'll automatically get linearized. So we're going to set our minimum arc radius here. I'm going to set it to 4/10,000ths of an inch. It really depends on kind of the smallest arc that you guys would see yourselves generating at the toolpath sides, or at the toolpath itself. Now let's go ahead and go a little bigger. So minimum arc radius, I'll say 2 thou. And that is going to be 0.05 millimeters. Maximum arc radius. So this is a really good one. If you do the math and you look at a 1,000 inch or 999 inch radius arc, and you look at a small segment of that arc, it appears almost flat. I mean, measurement-wise, you have to go a pretty far distance before you get any change in delta on the other edge. So a lot of times for this maximum arc radius, I'll set it to something 100 inches, 80 inches. Kind of really depends on the maximum size parts that you're doing in where you would want to represent. What you don't want to have happen is you don't want Mastercam to take a line and convert it into basically an arc that is almost flat. So you've got, some 800-inch arc. It's just kind of, I don't want to say it's a bad programming practice, but it can lead to errors pretty quick. So what I'm going to do is make this, say, 123.4 inches. So that's the maximum arc radius that I'll be able to create. It's a large enough arc. 123-inch radius, 246-inch diameter. That's a large arc. So, but a much more reasonable number than 999. So just keep that in mind. So if we say this is 123.4 inches, it's roughly 3,100 millimeters. So we'll just go 3,125 for the maximum arc radius for metric. Minimum change in arc plane for helix. So what this is looking for is how much Z movement is present before Mastercam will allow you to output a helical move. So if you're trying to do a very small helical entry, this occurs a lot on thread milling. You want to make sure you've got a small enough value here. I like to use 10 millionths. So 10 millionths in metric is 0.00025. So maximum deviation in calculated arc endpoint from machine grid. So this is a nice one. Arcs have a tolerance. Everything's got a tolerance. So if you look at your machine and all the achievable positions numerically, the achievable positions are going to be based on the least increment input. So the increment input is what is the minimum movement amount that the machine can make in X, Y, and Z. So on an inch machine, a lot of inch machines, that's 1/10,000th of an inch, 0.0001. Some machines, it'll be 10 millionths, 0.00001. Or, on the metric side, sometimes it'll be 1 micron, sometimes it'll be 1/10 of a micron, sometimes it'll be 100th of a micron for a really super accurate machine. So what this is telling Mastercam is what's the maximum amount of error that is permissible for that arc. And the nice thing here is that if the arc doesn't fall within this tolerance, all that means is Mastercam is going to break it into a series of line moves. So the worst thing that's going to happen, and it's a safety mechanism, it's a benefit to you. The worst thing that's going to happen if you've got an arc that doesn't meet this maximum deviation value, if you've got a deviation that's larger, it's just going to break that arc. So don't be afraid of this tolerance. One of the things I like to do is I like to make this 20 millionths. So on a machine where my minimum input increment is 1/10,000th of an inch, I like to make my error 1/5 of my least input increment. So in a case of a machine that has a 1/10,000th of an inch input, I would do 10 millionths. I believe this machine's got 5 decimal place input. So what I'm actually going to do is make this 2 millionths. So I am basically, let's go, because I can't go 2.5 because 6 digits is the max that I can do on this box. So I'm going to make my maximum error 2 millionths. If the arc is less accurate on the endpoint than this, and actually, sorry, not 2 millionths, I'm going to go 4 millionths. So if my arc endpoint is not within position by 4 millionths of an inch, that arc is going to get broken. And I may be able, depending on the input increment, You may be able to adjust this, but keep in mind you want this to be nice and accurate. So I'm also going to do, so 1 micron here is 40 millionths. So I'm going to do 1/10 of a micron, which is 4 millionths. So now these values match each other. So I've set up my tolerances. We'll start going through the settings here. Remember here, I'm just setting the defaults. So underneath posting errors, I'm just going to make sure it's set to on fatal errors. Suppress the variable reinitialization messages. I want that turned on. I'm going to turn on transform nesting and source operation parameters. This has to do with data that's available to the post for transform ops, so I'm going to leave that on. You can set your post processor defaults here, so I could set this to overwrite, for example. It's just going to change the value of this. I still have to press OK to fire off the post action, so that's okay. Under NC output, I'm going to change the start sequence number to 1, the increment sequence number to 1, and the max I'll leave at 9999, 9999, 4 nines. I'm going to set maximum characters in NC comment to 80. And that's just, there are some machines that have a character limit, a maximum number of characters that you can put. Some machines, depending on parameters, will actually break the comment and allow it to wrap. Some will just throw an error. So actually, I'll set this to 120 for now, and we can change it if needed. The other thing that I've noticed about my customers, they don't have any spaces between the NC addresses. So I'm going to set spaces and end of block characters. I'm going to set that to 0 for the spaces between NC addresses. We'll keep on going down here. I'm going to go to the work system. We'll go to tool, and we're going to tell it add to tool 0 and 0 for the tool offset registers. So basically whatever the tool number is, the register length and diameter are just going to match that, so it's not going to add anything to it. This particular machine, I believe, does not have random pocket assignment, so we're not going to enable stage tool routines. Well, let's try it. So I'm going to turn it on. We can always turn it back off. Under ARC, this is where I typically make most of my changes. Many times I will use this option for only support helix motion in the XY plane. Lathes, sometimes you might not want to turn that on, but I'm going to turn it on. Only in the XY plane. For the arc center type, I actually noticed these guys are using radius, so we'll do radius. We're going to tell it to break at 180. That's fine, because with radius we don't want to go beyond that. Actually, you know what? I'll just break it quadrants. If we're going to do 360 degree arcs, I will always use delta start to center, which is the IJK option. And if we're doing 360 degree, we want it set to don't break arcs. So allow 360, don't break arcs, delta start to center. All three of those need to be set for it to work properly there. So let's actually, we can come back to this. I'm actually going to go delta start to center, delta start to center, and don't break. And we'll just do all planes. I think that's fine. Under everything else, machine cycles, all this stuff, we can turn off can cycles. We can do a bunch of other stuff in here. One of the things that's important here is this text. So the text, it's telling us right now, system post text is active. The text is not editable. It's not editable because we're editing the defaults. That was funky. Not sure if it resets. So it looks like something happened without me pressing save. So I'm just going to go through this real quick. You know what I'll do to save time? I'm just going to go ahead and select our post processor. So, it looks like we changed types. That's what happened up here. So we changed control types. I'm going to go back to mill. I'm going to look at tolerances. Oh, yep, and we got reset somehow. So let's do this. I'm going to add my MH320 post. I'm going to select it in the list, and I'm going to press save. Pressing save checks the post to make sure it's valid, and will write info to the back of the post. So I'm going to close the post processor, make sure it's closed. And now let's just go through tolerances real quick. And I'm only going to worry right now about setting the inch values. Minimum arc length, let's say 2, minimum arc radius, maximum arc radius, we'll just go 140. Minimum change in plane for helix, we'll do 10 millionths. We'll do 40 millionths here. And we'll save that. Okay, let's make sure these are set. So because I've actually selected a post, now when we come to the miscellaneous integer values, I can actually set default values. So this particular post has got some functionality that's built into it that allows you to control at the operation level what the output from the post processor is. So you notice miscellaneous integer number 2 controls absolute or incremental mode. So our code output, we can either have it be in G90 absolute or G91 incremental. Safe index. So for supporting horizontals, we have this function called safe index that's triggered by miscellaneous integer number 4. Feed per revolution. So for tapping, if we want G95 output, feed per revolution, we just have to turn it on with miscellaneous integer number 6 in the operation. So let's go through, turn on stage tool. Break. Make sure all these. So here in the post text, because I've got the control definition manager open and the post closed, if I change one of these strings here with this post selected, it's going to edit the strings at the bottom of the post. So this is how I can set up the miscellaneous integer values at the bottom of the post and have those be available to me inside the Mastercam operation. So right now, for example, high speed mode is set up for miscellaneous real number 1. We would want to use a value of 2 for AICC. And then XL decel value we would put in miscellaneous real number 2. This is also where we can go in and customize the drill cycles. So we can customize the names of the strings that show up in preparation for making additional edits to the post processor as well. So we've got this set up. I'm going to hit save. Now what I'm going to do is click the drop down and go to my defaults. I'm going to go to my ARC page. I'm going to right click, choose import all pages, and I'm going to choose the exact same file I've been working with and say open. And now I'm going to choose my post processor settings and choose OK, and it's going to import all of those settings from my post to my default settings. So now I can save it and press OK. Next step is to go to my machine definition. So I'm going to open up my machine definition, open up my MH320A machine, and now in this machine definition interface here, now I'm going to put in the name here. So it's the MH320A. It's a 4-axis HMC with a FANUC 31i, and it's set up for MCAM 2021. You notice under the control definition right now it's pointing to MP master. So I'm going to press the open button there, and we'll choose the MH320 and say open. And now I'm going to save it. And after I save it, I'm going to press open, and I'm going to open the same exact file again, because once I reload it, you'll notice that now my post processor shows up in that list. So inside, this is how this is arranged in my machine configuration. I'm going to go to my automatic tool changer. We're going to set this up for 40. And we're going to say minimize indexing time for the indexing method. And that doesn't really do much. It can adjust kind of your backplot time depending on the number of tool changes you've got. You notice there's an option to tell it to time to index between pockets, the actual tool change time. Let's give it 2 seconds. Now under the spindle, so if I double click on the tool spindle, this is where we want to set the actual RPM. And I believe the actual RPM on this guy is 15,000. I can actually go to website and just go MH320A, 15,000 RPM, 20 horse motor. That's what I thought. Okay, so data, any of the data that I might need: rapid traverse rate, 50 meters a minute, 1968, 41 RPM, maximum speed for the 4th axis, cutting speed, or cutting feed rate, 787. So this is all important data. So here, 15,000, I'm going to set the minimum for like 50. So that spindle speed will actually get read by the Mastercam operations when we're creating tool paths. So it's important we include that there. I'm going to go to the B axis. You notice it's set up for -y for being the 0 point, which is correct. Signed continuous, all this stuff is good here, so we'll say okay. And in order for this to be a valid machine, we have to have all the axes arranged properly, which is done in axis combinations. So I'll go to axis combinations. You notice we've got X, Y, Z, Y, X, and B. So all 4 addresses are properly included in our default machine definition. Now, by the way, I can create a 4-axis machine definition and a 3-axis machine definition. If you want to be able to create 3-axis code that does not include a B-axis address, you can do that through the machine definition. So what I'm going to do is just rename this to the 4-axis default. And I'm going to right click and create a new axis combination. And I'm going to call this 3-axis no B. And on my 3-axis axis combination, I'm going to select X and the machine table without selecting B. And then I'm going to do Z, Y, and the tool spindle. So here I've got X, Z, and Y. Here I've got, I'm going to do this real quick. In my 4-axis, I'm going to unselect everything. And I'm just going to do that so that I can select X, then Y, then Z, then the spindle, then the B. Oh, I was going to see if it would let me do X, Y, Z, but that's probably based on how the axes themselves are arranged. And these aren't necessarily arranged in the correct order, but it doesn't affect anything on the post side, so I'm going to leave it as is. So we'll select those. The last thing I need to do in here is go into my general machine parameters. So general machine parameters is where we set up some defaults for the Mastercam operations. So minimum feed, 1/10 of an inch per minute, maximum feed, we know that number, that's 787. So if I convert it to metric, that looks like it's 20,000 there. So 787.4, that's what we're going to call it. Don't need to worry right here about inverse time. So for rapid rates, for cutting rates, you notice apply to all rotary axes. So maximum rotary axis feed rate, 36,000 degrees per minute. Well, we know the maximum speed of our B axis is 41 RPM. That's under feed rate. I don't know if we have a rapid. Tool change time, tool to tool, 2.5 seconds. So I can go back and I can edit that if I want to. 60 degrees. All right, that's fine. So under here, degrees per minute. So 1 So we can set it right in here. So 2460 degrees per minute. And then linear axis rapid traverse rate. So what this affects is backplot. Sorry guys, just switching over. Switching my webcam, making sure it's active. So if I have this set applied to all linear axes, whatever number I put in here is going to be the rapid speed for each axis. If I go back and I look at my technical data here, rapid traverse, 1968, 1968, 1968. Because they're all equal, because it's all the same rapid speed, I can just put it right in here. So I can just say, you know what, this is 50 meters per minute. So I'm going to put in the 50 meters per minute. It's going to do the conversion, 504. So that's going to give me my maximum rapid rate, 1968.5 for inches and 50 meters per minute for metric. If I had different rapid speeds for X, Y, and Z. I could turn this off, apply to all linear axes. And if I turn that off and I go double click on X, I can go set my rapid traverse rate down here. So if I set this to 19, so say for example that this was 50 meters a minute. So I'm going to convert that over to inches, 1968.5 for X. And then for Y, I'm going to go to Y. We'll do that. But now let's say, for example, that instead of 50 meters a minute, what if my Z-axis was only 40? Well, here I could go and type in 40 meters per minute. 1574.8. So in this case, if I had a rapid motion, it would actually show the difference between X and Y and Z as we're moving from point to point in a linear fashion. You're going to see the break, sometimes called a dog leg. So here I'm going to set this back to 50,000, do the conversion and say okay. So I could set all of my travel limits for all of the axes, but it doesn't really do anything for me unless I add logic to the post to do something with it. So in this case, I'm all done configuring the linear rapid. For tool plane, I'm going to set my default C plane to front. Under tool and materials, we're just going to leave all this. So under coolant commands, this is set up for what we call version 9 style coolant. It only allows us to have one coolant on-off command. Choose between 3 different options, but only one at a time. And then it only allows us one off command. So I'm going to turn this off here. I'm going to leave on first coolant off command, shuts off all coolant options. And then we've got flood, mist, through tool, and we can do something like wash down. And we can add the extra strings that we need. By the way, it's going to read the string that we put in here. So if I go to wash down coolant, and I say this is, M53, and off is M55, it's actually going to read these M values from this dialog. So it makes it a really easy place to go and configure your coolant commands. I think it might be M57 and 59, so I'm going to have to check on that. And then through spindle is typically, it's either M07 or like M5051, so I think it might be M50 on. So I'll have to check those values. But this is where we go to set up the coolant. So I'll select OK. Everything is done here. I've selected my control definition, which in turn is linked to my post. So I'm going to save this, and I'm going to press OK. And when I do that, I'll go ahead and do File New. And now I can open up my example file. And this was programmed for a vertical machine. So what I'm going to do is just minimize this and leave this machine group in here, because this is programmed for a vertical style machine. So in this case, I'm going to go to my machine tab, and I'll go to mill, and I'll go to manage list. And here's my new MH320 that I just created. So I'll select add, and then OK. And then under my machine type in my ribbon, I'll choose mill, and I'll choose my MH320. So what I've done is I've added a second machine group here. So we're going to call this MH320A horizontal setup. And in order for this to work for me, I'm going to go to my levels here. I'm going to select everything. And I'm just going to copy it. And we'll start on level 200. And we'll call this horizontal. So I'm going to copy all of my part geometry, everything else, turn off all the other levels. And now what I'll start to do is start to kind of break this up. So I'm going to take my two pieces here. I'm going to move them to like 210. And we'll say this is we're just going to call this op 20 for this particular setup because I'm setting it up for this horizontal machine. I want to be able to differentiate it from the other part that's programmed. So we'll just call this op 20 stock. So I'm going to say move. Now, before I get too far along with moving things on levels, I need to completely reorient this part. So underneath my planes, here's my top. There's X, Y, and Z. So what I'll do here is right click on top and I'm going to choose duplicate. And then I'm going to right click and I'm going to rename it. And we need to name this something that indicates that it is the horizontal WCS. So what I'm going to do is just name this op 20 top WCS, and sometimes I'll do something like depending on where I'm programming from, you can call this G52 if I'm programming off of center of rotation, but we'll just call this op 20 top WCS. So this is how the machine is going to be set up. And what I want to do is reorient all of this part geometry. So I'm going to select it all, and under my transform ribbon, I'm going to choose the option on the drop down here for translate. And you'll notice I've got dynamic, I can choose regular translate, I can also translate to plane. So I'm going to do translate to plane, and I'm going to select move. And my source plane is going to be from the right side, and my destination plane is going to be bottom. Now what that's going to do is that's going to put everything basically almost where I want it. It's just flipped around 180. So, or 180 relative to the top view. So I'll select OK here. In my planes dialog box, I'm going to select op 20 equals. That's going to set my construction, tool plane, and WCS to this op 20 here. So there's all my geometry. I'm going to grab all the geometry and select it. Now that I'm in this plane, which is essentially the top plane, I can rotate it. So I'll select move. We're going to rotate it 180. And I probably could have done all of this with one dynamic operation. So that's the other thing to keep in mind here is I'm using multiple steps, but I don't really have to. So then the last thing here, I'm going to make sure I'm in 3D mode. So I just right-clicked. I check my status. I can also check my status down here. But what I want to do is move this so that the bottom here is basically at the top of my palette for my horizontal. So I'm going to choose Move to Origin. And it says select the point to translate from. I'm going to choose the center point of that bottom circle. And that's kind of the last step that I've got to get the part into position for horizontal machining. So I'm going to do Home, Clear Colors, and if I look at this from the top, I've got my two parts set up. We've got this vise and this kind of trunnion style fixture plate that is going to hold onto it. And in order to set this up on the post side, I'm going to need some tool paths. So in order to start programming from the front of this, in my planes, I need to make sure that this is my WCS, but then I need a front view that's relative to this plane. So I could use any of my system planes here, but I like to create my own planes so that they're all kind of linked together. Now, one of the benefits of horizontal programming in Mastercam, and it's been this way for a long time, if you use the front plane, you'll notice your z-axis points straight. If I look at this from the top, but I click on the front plane, you'll notice the Z points towards the spindle. If I click on the right side, the Z points towards the horizontal spindle if this were to spin 90 degrees. If I click on back, the Z is going to point towards the spindle, and if I click on left, the Z is going to point towards the spindle. So the default front, right, back, and left planes will give you B0, B90, B180, and B270 when you post without doing anything. It's all built into the software kind of by default. It's just, unless you know about it, it's difficult to take advantage of it. For my top plane, which is, I mean, it's my new top WCS, but I've renamed it to Op20. Let's go to isometric. So Op20, I am going to right click on it. Oh, and the other thing here is, this is my WCS, but I need my front plane. So I'm going to right click. I'm going to do create relative. And what I'm going to do, and I'm going to do this one at a time. And the reason I'm doing it one at a time is so that I can control the order of the plane creation. So I'm going to do front, and we're going to call this B0. B0 front. So you notice it adds B0 front. I'm going to select Op20 again. We're going to do create relative, and I'm going to go to the right side. B90 right. Create relative. And I'm doing this in this way so that I get them in the order that I want them. B180 back. Last one. We're going to right click. Relative. We want left. Okay, so I did B0, B90, B180, B270. So I've got my 90 and my 270 to get to either end of the part. The last one that I need, we've got this, basically this -15 plane. So the way this was set up originally, you notice here's A0, even though the part's not oriented correctly for that, but there's A0, and then we had A -15, which was Let's see. So that's going to rotate towards the 270 side. So here's what I'm going to do. I'm going to select the front, B0. And I'm going to use my drop down here to do a dynamic plane. So I'm going to hit O to have it move the plane to the origin. And I'm going to reorient from top to front first, and then I'm going to clock this to minus 15 degrees. So we're going to call this B minus 15. We'll just call it B minus 15. That's fine. And we'll say OK. Now, one of the things that I'm going to do, we've got our front. If I make this my construction and tool plane, I'm going to set my work offset manually. And I'm going to set this to 0, which is going to give me my G54. Then on the right side, I'm going to set that to 1, which is going to give me G55. Back, I'm going to set it to 2 for G56. And then left, I'm going to set it for 3 for G57. So I've got G54, G55, G56, and G57. And then on this B15, I'm going to set it to 4 so that I get 58. So I'm going to do G. We're also going to label these. Because I know that based on the numbers that I'm putting in here, I'm going to get a work offset. So I might as well do the work up front to remind myself where this is going to be. So 55, and this one's going to be 54. All right, so I've created my planes. I've created my new post, machine def, control def, and now I want to go do some programming. So in my planes, I'm going to go set op20 back to be equals. But what I'm actually going to do is set op20 to be my WCS and B0 front to be my construction and tool plane. Then I'm going to save it. Part of the reason I'm doing it in this order, I've got some sample toolpaths. But if you notice, the WCS changes through to match the tool plane, and that's not the way that I prefer to program. So I'm going to do this. I'm going to copy these operations. So I'm copying from one machine to another, and it tells me dropped operation compatibility. All of the selected operations will not run on the group's machine. If possible, they will be modified to run properly, or they will be removed from the selection. Do you want to continue with the copy move? I'm going to go down to details. And details is going to tell me what's wrong. So, machine operation compatibility errors. Operation, contour, rough top. Operation parameters must be modified. Details. Coolant setting is invalid for the machine and should be revisited. Now, what you're going to see as I go down through this list, the only problem is coolant. It has nothing to do with a problem with the operations themselves. It's just the coolant that's messed up. So I'm going to say go ahead, OK. Similar tool already exists. Do you want to use the existing tool? Do you want to create a new tool? We're going to say use the existing tool. Yes. So I've immediately copied these operations down. I'm going to select them just to make sure these other ones aren't selected and only these ones are selected. And I'm going to right click, edit selected operations, change NC file name. So this one we're going to say 1, 2, 3, 4, 5, 6, 7 horizontal. Up here, I'm going to change this one. All right, good. So that's got a completely different NC file name. And I'm going to select it, edit selected operations, change program number, and I'm going to make it 3456 for the program number. So it's completely separate. And now what I want to do is go through and change the WCS and tool planes for these parts so I can run them on a horizontal. So I'm going to change all the planes first, then I'm going to go select new geometry. Finally, I can post out and do some post edits. But in order to do that, I really need to select operations that only use the same tool and construction plane, because whatever I select, it's going to change everything. And I don't want to just change everything to top. I want them to be able to have control over the actual plane that's set. So here's what I'm going to do. I'm going to set my planes first. My WCS is set to op20 top WCS. B0 front is set to my construction and tool plane. So I'm ready to go for horizontal programming. So everything that is A0, I am going to select. A0, 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 A0. So all these ops use A0. So I'm going to hold down, right click, and choose Edit Selected Operations, Edit Common Parameters. And in this dialog, I'm going to go choose Planes. And what this is going to do is this is going to grab my active plane settings. My active plane settings is top op20 WCS, and then B0 front for the tool plane and construction plane. So I'll say OK, OK, and it automatically makes them all dirty, which is good. I want them to be, because I'm going to go and reselect geometry. Well, actually, the geometry should be, well, technically I copied this geometry, so I didn't move it. So I'm going to have to reselect stuff, but that's okay. So now I can go to anything that's minus 15. So I'm going to go minus, so I'm going to go change my plane. Minus 15, G58, I'm going to set my construction and tool plane to that. And then under toolpaths, I'm going to grab everything that's A minus 15. Minus 15, minus 15. Those are all 90. So I'm going to right click, edit common parameters. We're going to go planes. You notice that it all comes in matching what my existing planes are. And then the last two here are at 90. So I'm going to right click, edit common parameters, and then we go to planes. And in this case, I can just choose B90, 90. So I've got all my planes correctly set now, because all my WCS is set to op20 top. And by the way, one of the things I like to do with this, so if I was to go post out this set of operations, and I want to be sure my part's not moving, that it's not changing, one of the things I can do is just right click and go to my display options, and I can turn off operation comments, all this stuff, so that only my WCS is shown. So if I have 150 ops, I typically will only change the tool and construction plane between the ops. And this is a great way that I can filter that data so that I'm just looking at what are the WCSs that I'm using. So you notice down here for this group, they're all using the same WCS, which is typically what I want to see. So then back in display options, if I turn off WCS and turn on tool plane, now you can see that I've filtered just on tool plane. So I can see the changes, even though my WCS is all the same, I can see the changes between my tool planes fairly easily. So display options, I'm going to turn on WCS, turn on the comments, and I'll save it. So what I want to do here is just set up, I'm only going to do the top part. So I'll save that. So on my levels right now, I've got my stock here on level 210. I've got everything else here on level 200. So I need to start kind of differentiating this geometry. So I'm going to take this group of solids here. We're going to call this fixture base. I'm going to set the force the visibility to off. Now we've got this fifth axis vise. That looks like most of the vise parts, so I'll right click. Let's go. Make this 204. Make that the vise. Move that to 204 as well. All right, so here I need to, let's see, rough the top. And what do I want here? So what I'm really doing here is I'm not worrying so much about actually programming features on this part, because what I want to look at is the configuration of the code that's being output, and I don't really care so much about the accuracy of the toolpaths themselves. I care about the rotations happening, and I care about the tool changes happening, not so much what is being cut. So just keep that in mind. So here, I'll go in and I'll rechain this. So I'll do a cut on the top. Let's see. Let's do linking 0, 0. And one of the things we have to be careful is making sure we've got enough clearance on a horizontal, because right now the way that we've got this programmed, we have to make sure that we've got enough retract as we index so that it's not hitting anything. I mean, if we look at the kind of fixture that we've got here, you'll notice the part is pretty close to the center line of rotation. But what I'm going to do here to make this more realistic, let's do this. Let's do I'm going to look at this from the top view. We're going to set our planes to be the top view. So I'm going to set this to be equals. And I'm going to move this in Y minus 10 inches. I'm just going to put it there. And we'll save. And that way, you can do this. So I'm going to go to Modify Feature. Double click on these holes. We go to Push and Pull. We'll pull that up like 10 inches. So now, just going to go Analyze Distance. And it is 4.75 NY. Okay, so now we've got our part more realistically set on not the center line where, you know, where we're offset a bit now. So under toolpaths, if I regen, I've got my toolpath there. So we'll just rechain. And here we're going incremental off of everything. Just do like 2. And now here's an interesting thing. Go 1 incremental. I'm just going to go 1 inch incremental. And I'll show you this in just a second here. So this thing. So I've got these 3 paths, and they've all got a pretty low retract, and that's on purpose. And what I'm going to do is I'm going to go to the first path, and I'm going to go to my home reference points, and I'm going to set my approach to be 6 inches incremental. Actually, no, let's set it absolute, and let's set this to be 10 inches. So on the very first toolpath, 10 inches is not a lot. Okay, so let's go 14. Let's go 12. 12 is fine. So I'll go 12. Now my first path has a nice far retract. And then on the very last path, because I know I'm going to rotate over here, the very last one, we're going to go retract to say absolute 11.5. So as I work these 3 ops, I do this high approach, I make my cutting, and then I retract out before I index. So here I'm indexing. Okay, there's some of my index geometry. All right. So, turn off my stock. All right, so here going to go to single chain. Let's grab that guy. And on this guy. So what I've got going on, I've got my cut coming in there, it's jumping across, doing my cut on the other part. But as far as indexing goes, my last path was here. So there's my retract. So what I want to do on my first path here is go into my reference points and do an approach. And let's do incremental like 3. And then that way, the retract here and the approach over here aren't going to collide with anything. And then I'm going to do a retract here of like 3 inches as well on that last one. So then I go back to the front. Make sure these are all incrementals. Okay, so we got to cut there, cut there. Now we go back to minus 15. Okay, so we got to fix all the incremental settings here. Incremental. Incremental. So, and again, these numbers aren't necessarily going to be right, and I know that. The important thing here is that we have a series of operations that have a change in cutting, well, a change in operation without necessarily a physical tool change. So like op, all in a row, all in the same plane. And let's see, that goes back to B0. So here we're going to do a 3-inch approach, incremental, and finally a 3-inch retract on the last one here. All right, so minus 15. All right, so let's see here. So I'm just looking at what do we need to actually prove this out. We only need a few more cuts down here. So we got B minus 15. so this goes back to B0 front. That's fine. Okay, so we've got that guy at B0, that guy at B0. Okay, so these last two, we've got some cutting, and then we're going to B90 right. So okay. So what I've got now is a series of operations where I've got some cutting at B0, some cutting at B minus 15. Go back to B0, go back to B minus 15, go back to B0. Now I go B90. So I've at least got incremental 625. Top of stock is 0. Incremental. Let's go 4. All right. So if we look at this from the top view, we can see the cutting we got going on. So now that these are all set up correctly, I can go ahead and post it. And by set up correctly, I don't mean that it's going to cut a good part. I mean that we have some sample toolpaths that have some tool changes, they have some null tool changes, and we can actually look at the code output and see what we're getting. So let's see what we're getting. We've got some data that's coming in the header, which is good. We've got our program, overall min max, and we're getting kind of the normal stuff that we would expect to see. Now we need to look at a couple of things. So coolant settings. I'm going to select them all, right click and hold, edit selected operations, edit common parameters, and I'm going to go to select coolant, and we're going to do flood after, because that's the coolant method that we want to use. And then I'm going to repost, and we can see what we're getting. And what I did with that, I moved this coolant code on after the G43 line. So if I look at my example code of what we want to use for configuration, this is kind of the sample that I was given for how we want the code to look. So right at the beginning, you notice we've got this tool change. We've got N01, and then the tool change M6, and then we want the speed right after the M06. And then the M03 line gets moved down to the G43. So here's that M03 there. So what I'm going to do is do file open, and we're going to go to our mill post folder for shared MCAM 2021 and go grab our post file, and we'll start looking at making some edits. So first thing I'm going to do as I look through my post, I'm going to scan down here and we'll make sure that if there are any options to set, we set those first. So getting into general output settings, force XY output on all drilling lines, including the cycle call. Yes or no? I'm going to say yes because I like it as a good safety feature. Hostile pec drill and extended offsets, we're going to leave that off. WCS type, it's automatically set to G54, so we're going to leave that. Force, even though it says WCS, what it really means is do we want to force the output of the work offset at every tool change, and I'll say yes. Output Z, I'm going to change this to no. Coolant with the Z move. Coolant off with last move, we'll say yes. Use pitch, and you notice it says use feed for tapping or use pitch for tapping. We can choose that option here. I'm going to leave that set to 0 for feed. Rigid tap, we've got rigid tap turned on. I don't want to go too fast through this. Alright, use rotary lock unlock codes. We can leave that off for now, but if we need to turn it on, we can do that. So down here, T sequence number, T SEQNO. Output sequence number at tool changes. When omit sequence is yes. So 0 is off, 1 means sequence number matches the tool change number, 2 sequence numbers match the actual tool number. So we either want this 1 or 2. If I look at my sample code and I do N01 and I'm going to search for M06 to get to each tool change. So we've got N1 T01, we've got N2 T02, N3 T3, N4 T4. So it looks like, now this is important. So we go from N7, I go next tool change, N8, I go next tool change, N2. So the number even though it's down at the bottom of the file, matches the tool number, not the tool change number, which is an important difference. So in my machine, I'm going to go through the machine definition manager. We're going to open up the control definition. I'm going to go to NC output, and we're going to turn off the sequence numbers. So omit sequence is yes. And we'll save it. Replace the machine. And we'll save it. So in our post, save that, T sequence number. So sequence number matches tool change number. 2 is sequence number matches tool number, which is what we want. So I'm going to make T sequence number set to number 2 here. We've got force output, so force output of all G codes. Safe index currently hooked up to miscellaneous number 4. This is all good. So all the rest of that stuff should be good. So those are kind of the default switches we want to check. Now that I've changed those options, I'm going to repost. And what we should see is some changes to our NC code. So you notice we've got N1, T1, M06. So first thing I'm going to do, I'm going to go to my post processor and I'm going to find my formatting for $. Right now, the tool numbers are set as integer. So this is the format for my tool. This says, this is the variable, $. This is the number that gets applied to the variable. And then this is the string in front. So for my format statements, I'm going to go up to the top here. Here's where my format statements are. So format statement number 4 is just integer. So it's integer, not leading. Format statement number 5 is integer, force to leading. And what we're talking about here is leading zeros. So what I'm going to do is change the format assignment. This is the format assignment line. I'm going to change this to a number 5. And my sequence number, which is my $N here, I'm also going to change that to a 5. I'm going to save that. And now when I repost, what I should see is that I'm now getting N01 and T01, which is what I want. I wanted this to go from N1, T1 to N01 and T01. Okay, so now what I need is I need my spindle speed to show up after my M06. So what I'm going to do is I'm going to search for M06 in the post. So here is my code, my first set of code that is going to output from my tool change common block. So here's my M06 with my tool comment. So what I'm going to do here, I'm actually going to create a new output line. And I'm going to copy paste p-tool comment up there to put it on its own line. And I'm going to get rid of p-tool comment here. So down in my actual output code, a little lower on, lock, unlock. So we've got if safe index, else, and here's where my speed codes are coming out. So here's the else. Here is my PF spindle out. So part of the problem is that PF spindle out gives me this guy right here, which is going to output both my speed and my spindle command. So the way this is built is it's built to output the M code and the speed command at the same time. So what I'm going to do is spindle out right now is set for speed and spindle. So I've got speed here and then spindle. I've got force speed here and force spindle. And this is PF spindle out and P spindle out. So these are where my spindle codes are going to come from. It's from these two post blocks. Spindle speed and M code. Spindle speed and M code forced. So it's really the same thing. And what I am going to do is I'm going to take out speed. And I'm going to take out forced speed here. So it's only going to be the M code. So spindle M code output forced, spindle M code output. And do another search here. So PF spindle out. So so here's my safe index. Here's PF spindle out, which is going to be the M code. So that's with safe index. Else, we've got PF spindle out down here. PF spindle out. So what we really want to do, based on the way that our code looks here, is right after the G43 line, that's where we want to put our MO3. That's where we want to put our spindle out. So here's our G43 line, here's our tool length number, here's our Z output. This is where we want our PF spindle. So, do that. So we're going to cut this. Control X, and we're going to do paste there. Okay, so PF spindle out. We've taken it out of here. It is also here, so we're going to take it out of here. And in our MO6, I'm going to get rid of the tool comp. And we're just going to force the speed output. So I've moved the output of speed. Else I need to make this into its own nested post block because we need this here. So I've got that fixed. So now by moving this speed at the end of the MO6 and putting this PF spindle out after the G43, if I post it now, and we post it, we are now getting our N1, T1, M06 spindle speed. We get our approach move. We get our G43, HZ, M3, T2. And then we get our coolant on M08. And if I look down at our transition, it'll be 0 there. Fin ext profile. So what do we got? So now here's our angle where we're going and just changing the angle in there, and that's good because it's not changing the tool. But if we look here, instead of G91, G28, Z0, we're doing a G53, Z0, MO5, and we're doing a G49, MO1. So we need to change P retract. So if I go to the post file here, and let's see, P tool change 0. So down here, we could potentially be getting G43 output as well. So we want our P spindle out. So P spindle out is going to come on after the Z. There's our P spindle out. So we want to make sure that we remove it from a couple of spots. And we've got our safe index and else. Beacon. So we're gonna go. So what we're going to do is actually do speed and so that's there. And what I'm doing there by including the speed, we'll actually get the spindle speed coming out on this line. Here, not there. Yeah, so we got our speed coming on, and then our M03 will actually be output by this P spindle out. So P spindle out was just going to output the M code, M3, and then our actual speed value gets output here. So that should fix that, but we also need to look at our retract. So P retract, end of toolpath, tool change. So that takes care of the coolant stuff. Here's our M05. And if we look at it, on the spindle offline, on the M05, we just want G53Z0. So we've got cancel rotation coordinate. G53. So there's our G53Z0. Don't care about this coolant. So all the coolant off stuff's going to come before that. We want SG code. Alright, so it shuts off the comp. So we get a Geo. Actually, we don't even need a Geo, do we? No, we don't. So undo that. Do that. Okay, so we just want the G53. We do want $E$ for the comp. So we got the comp. We got G53. We got off there. We don't want that. That should be the rotary. But now, where's our MO1? So let's search for MO1. Here's the MO1. Tool change com. So here with our MO1, what we actually want to do is create another G49. So we want a string literal right here. So whether we're getting an MO or an MO1, we get the G49 ahead of it. So by putting it there, what we should get when we repost this is a little smaller. Okay, so we're getting our regular tool change there. And then if we look at our retract here, we're getting our coolant off. We're getting our G53Z0 MO5. We're getting our G49 MO1. Then we start up our next tool change. And if we look at kind of the structure, I think we're good. I think I may need to turn my min-max Z switch back on. So right up at the top, output Z, min-max Z values. We're going to go with yes. And we're going to save that. Alright, so we made quite a few changes. I made them pretty quickly. I realized that a lot of this was really just, basic setup. How do we go through that? And then how do we make some kind of different configuration changes? So I moved the spindle speed output to the end of the MO6. I changed the formatting for the MO1 and the N for the N number and the T number. Probably change next tool as well. Let me change that real quick. So if we go down to the format assignments. First tool, next tool, tool length number, tool length offset. So what I'm going to do is change first tool, next tool, tool off number, and tool length number to 5. What that does is that's going to force that leading 0 ahead of the first digit. So if I now repost and we look at these codes, what we should see now is TO2, HO1. Instead of H1, we're getting an HO1, and DO1 instead of D1. So, wanted to make sure we got that in there. We're still getting a retract here that's a G91 G28Z0, so that's probably P retract 0. So if I go to look at P retract 0, this is probably where we're getting our G91 G28 Z0. So abs inc equals 1 changes us to incremental mode. So I am gonna get rid of that. Abs inc equals 1, we're gonna get rid of that. Then down in P retract 0, we're gonna change this to just G53. Oh. So G53. Oh man. Okay. G53 Z0. Don't need SG apps inc. Z0 and so I'm just looking here. Some of the code. So I'm looking for is rotation. So I'm not seeing. So, window. So I'm not seeing a rotary code anywhere in here. J01, which is weird. G54 J01. I mean, I don't see any rotation. Yeah, so, alright, well, that's pretty much change this to G53. You know what? We're going to go G49 Z0. So I'm going to save that. Let's repost it. And let's see here. So 380. There's the actual tool change. But what happens when we don't need a tool change? Let's go. There we go. So G43, G49, Z0, G53, G49, Z0. That retracts us. We call up our new work offset, G58, B minus 15. We got our new position. We don't need a spindle on because the spindle speed has not changed. So if I go to right EXT angle, and if we look for right EXT angle, let's just make a change here. So let's go 5300 and let's repost. All right, so all right, 830. Right EXT angle. So here we need to change that speed because we're getting the MO3 before anything else. So we need P retract 0. So that's giving us the P retract 0, but now we need change. Tool change common. Change 0. And here's where spindle out. So let's see, we're getting this MO3. So I am going to, well, let's do this, guys. I need to chase down this speed and this MO3 issue, but we've been going for quite a while here, about 2.5 hours in. So unfortunately, I've got some dinner reservations. Well, I shouldn't say unfortunately, it's fortunate, but I've got some dinner reservations with my wife and my daughter. So I'm gonna have to wrap up this presentation for tonight. So let's go ahead and wrap up what we're doing with setting it up. I mean, we got pretty far with setting up the horizontal output. So we're getting, code that's real similar at the tool change for what we're looking for in our sample. And it looks like there's a little issue right now with turning on the spindle speed in a null tool change operation, but we're going to have to come back and look at that another time. So thanks guys for joining me. I know I just kind of threw a whole bunch of stuff at you, kind of with no warning. Here's how we set up a horizontal post. But really, a lot of this stuff is configuring input and output. So we've got input in Mastercam in the form of operations, and then we've got output in the form of NC code, and that post processor is the link in between them. But it's also influenced by the machine definition and the control definition. So both of those files have settings which also either influence the post or work with the post to output the code. So, well, hey guys, do you have any real quick final questions while you got me here before I sign off? Is there anything that I can try to clarify in the next couple minutes? Cool. Well, thanks for joining me, everybody. Hope you guys got something out of it. Hope it is helpful and educational to see somebody go through and do this type of work. So, all right, guys. Like I said, thanks for joining me, and I'm gonna wish you guys a great night and a great rest of the day this Sunday. And we'll try to do this again soon. So thanks everybody for joining. And the video will be up on YouTube if you guys want to review any of the content or see what did he do here. I know I went through some of it pretty quick. If you guys have any questions about this content, you want to see some more of it, you want to see me continue on with any of this stuff, let me know. Shoot me a comment on YouTube or drop me a line. So thanks, guys. All right, I'm going to shut down. It was a pleasure, guys. Have a great night, and I'll see you all later.